All right, back again. More chemical reactions. Again, these are reactions that potentially have been taken from previous question fours on the AB Chem exam. So, solid calcium oxide is exposed to a stream of carbon dioxide gas. So, first trick, let's just write down the reactants. Calcium oxide, know your ionic compounds, plus carbon dioxide. And now you're saying to yourself, what could happen there? How about a synthesis reaction? Carbonate is a product of carbon dioxide plus oxide. So oxides react with carbon dioxide to form metal carbonates. So our product here is going to be calcium carbonate. All right? Balanced reaction, no spectators. This is a synthesis reaction. So carbon dioxide reacts with oxides to form metal carbonates. So metal oxides react with carbon dioxide to form metal carbonates. Again, you may not get the whole reaction here, but even if you can write down the reactants, you get a little bit of credit. What kind of a reaction is this? We classify this as a synthesis reaction. Two or more things combining to form one thing. Notice there's no change in oxidation numbers here, no redox going on. This is just an ionic compound combining with a covalent compound to form a different ionic compound. All right. Next case, solid dinitrogen pentoxide is added to water. So dinitrogen pentoxide, hope everybody can write the formula for that. The name tells you N2O5 reacting with water. We talked about this in the last show. Non-metal oxides, like nitrogen pentoxide, non-metal oxides, react with water to form non-metal acids. Okay, so whereas metal oxides react with water to form bases, non-metal oxides react to form acids. So now you're thinking to yourself, what's my favorite nitrogen-containing acid? I hope you all think of nitric acid. So we'll write nitric acid here. All right? And then all you have to do is balance it. And very simply, I believe if we put a 2 here, that brings everything to balance. 2 hydrogens, 2 hydrogens, 2 nitrogens, 2 nitrogens. 6 oxygens. I've got 1 oxygen here, 5 oxygen. I've got a balanced chemical reaction. There we go. So a couple ways to classify this one. We could classify it as a synthesis. It's also an acid-base reaction. Okay? Is the final solution acidic, basic, or neutral? What do you think? Of course, it's acidic, which means pH is less than 7. And the reason is non-metal oxides react with water. Non-metal oxides, I speak faster than I can write. Non-metal oxides react with water to produce acids. A handy category of reactions to remember. Okay, these non-metal oxides reacting with water was the major source of acid rain, a problem that plagued the United States 20 or 30 years ago by trying to remove oxides from the atmosphere, particularly sulfur oxides. At least in the United States, we have kind of brought acid rain under control. That's not necessarily the case in the rest of the world. Sulfur dioxide and its corresponding oxides was one of the major contributors to acid rain. Guess which acid was produced? Our old friend sulfuric acid. All right, on carbon disulfide vapor is burned in excess oxygen. Remember, you're not responsible for putting down the states. So CS2 reacts with oxygen. Now we look at this and say, okay, I've got carbon and sulfur. Carbon is going to be converted to carbon dioxide. Sulfur is going to be converted to sulfur oxide, the simplest oxides. So there's our reaction. If we want to balance the reaction, what do we need to do? Carbon's in balance. Sulfur, I need a 2 here. And then I've got a grand total of 6 oxygens, so I need to put a 3 here. That balances my reaction. This is a combustion reaction. Combustion reaction is any reaction that has oxygen as a product, so we're going to call this combustion. All right, what is the oxidizing agent in this reaction? Well, the traditional definition of oxidation is adding oxygen. So the oxidizing agent is definitely oxygen. Oxidizing agents, okay, must gain electrons. Okay, so if we take a peek here, sulfur is going, let's check out the charges here. The oxidation number, sulfur is -2, carbon is +4, oxygen in the elemental state to 0. Carbon over here, oxygen is going to -2. So there we go. Oxygen is gaining electrons, it's being oxidized. The carbon is staying at +4. The sulfur, okay, is, again, 2 oxygens, -2, -4. The sulfur is +4. The sulfur is going from -2 to sulfur, although it doesn't ask if the sulfur is losing electrons. It's undergoing oxidation. So oxygen is the oxidizing agent, sulfur is the reducing agent. Again, this is an example of a redox, also a redox reaction. So many reactions, like the one above, can be classified in 2 different categories. So knowing a little bit about oxidation numbers is going to help you on the AP Chem exam. All right, finally, one more reaction here. Lithium metal is burned in air. All right, lithium. There we go. That's pretty simple. Is burned in air. So now we've got a choice. We could write 2 reactions here because we know that air is made up of oxygen and nitrogen. So pick one. Oxygen is more reactive than nitrogen, so the better choice is oxygen. Lithium reacts with oxygen to form lithium oxide. Okay? If you liked, lithium could react with nitrogen, a less favorable reaction. In that case, we would have lithium nitride. Either one of those would be acceptable. Okay? The lithium reacting with oxygen is probably the better choice there. Okay? Besides combustion, okay. Oh, notice they tipped you off there. Besides combustion, they are pointing to this reaction. So in the words here, combustion, what type of reaction would this classified as? What do you think? We would classify it as synthesis. We would classify it also as redox. Notice the lithium is losing electrons. Lithium is going to lithium plus. Oxygen is going from 0 to -2. So this is a synthesis or a redox reaction. Again, either of those answers would probably be appropriate. So this is, what do we call this? This is redox. Oops, lost my pen. Hang on. Get it back here. This is redox. This is combustion. This is synthesis. Okay? So again, the categories overlap. Synthesis, reduction, what else did I say? Combustion. If we look at it from the perspective of the oxygen. All right, 4 more done.